Hello my dear students, welcome back to the St. Joseph Composite PU College, Vijaypur. I am Rahul, chemistry faculty. And in this present video, I am going to discuss with you regarding the vapor pressure of liquid solutions, where the solute and solvent both are liquids. And for understanding that, let's take an example and from that we start the discussion. That is vapor pressure of liquid solutions. And for this, we have to take two liquids. Let me have one container over here, and in this container what we'll do that we'll fill two liquids. The liquid should be two here. Okay, this is a container. In this container I'm going to fill two type of liquids, and both the liquids are volatile. Okay, now let me take some liquid over here. This is the layer of the liquid, in that there are two type of liquids are there. Okay, this is the one. This is the one liquid, and there is one more type of liquid is there. Both are mixed and both are volatile liquids. Okay, and therefore it is called binary solution. Okay, and one thing is binary solution means there are two components should be there. Both the components are here liquids. Both components are liquid. Both components are volatile liquids. Volatile liquids. Okay, this is one part. So when these two liquids are in the form of solution, they evaporate. They evaporate and form, you can say that they form a vapor. Assume that this is the one vapor here, some vapor is there, and then the other liquid also is present in the form of vapor. Now the question is that how much vapor pressure is created? Because in the Henry's law you have seen that the vapor pressure it is created depends upon the number of, you can say that, solvent molecules or the mole fraction. Okay, but how we can identify that vapor pressure of the individual, or you can say that total pressure inside this container if it is closed? Let me close this. And for this there are two vapors are there. Assume that the red one, this gas molecule I consider as A, and blue I consider as B. There are two components are there. Two vapors are produced. Two different type of vapors are produced. And to understand the total vapor pressure created by the binary solutions or any type of solutions, so in that two or more volatile liquids are present, and for that we use here Raoults law. That is Raoults law. According to this law, we can identify that what is the pressure. What this law says? Law says very simple statement is given. At given any temperature, at given temperature, means the temperature should be constant here. Why we are using the term here given temperature means at particular temperature there is a particular amount of vapor is present. If you increase the temperature, the vapor will increase. Okay. For a solution of volatile liquids, for a solution of volatile liquids, volatile means the liquid which easily get evaporate. You can take an example of petrol. When you keep in a vessel, it get evaporate very easily. Okay, it means that the petrol is very volatile it is. Okay, volatile liquids. The partial pressure, whatever the partial pressure is created, the solution which contain the volatile liquids, the partial pressure of each component in a solution is equal to the product of the pure component and its mole fraction mole fraction. So this is very easiest statement is there, but looks like very more number of words are it contains. But we can go with the equations. By that you can understand very easily. Okay. Now the same container I will explain here. Let's assume that now right now here I have the you can say that the component A and the component B. There are two components are there, and the mole fraction of A can be given as xi A. The mole fraction of A, and P naught A means the partial pressure, or let me write here partial pressure of pure liquid. There is 100% of only A component is there. And for the B, we can write here xi B as a mole fraction, and P naught B be the partial pressure of pure liquid, liquid B I will write here, and let me write here liquid A. Okay. So when you are mixing these two liquids and forming a solution, at that moment what happens, the partial pressure, the total pressure of A can be given as the, you can say that in the solution we are talking about, in the solution what happens here, the pressure of, that is vapor pressure of A, or partial pressure of A in the solution, is given by P naught A into mole fraction of A. Hope you're getting this point. I will explain this. So assume that here whatever the pink color or the red color molecules are there in the vapor phase, and they collide with the wall of container and along with the surface of the liquid, and they produce a pressure. And let me write that the PA is a partial pressure produced by the A components, and PB be the partial pressure created by the, that is B components which are in the blue in color. Okay. Now if I want to write here PB, then I'm going to write here P naught B and xi B. Okay, this is the partial pressure of individual gases. Now what we can do, that we can sum up these two by using Dalton's law, that is Dalton's law of partial pressure. Dalton's law of partial pressure. And what we do that here, what the law is says that the total pressure P total equals to, if there is any container is there, assume that, let me draw one container to visualize this. Now there are two components, are minimum of two components I take. The one is here. So these are the gas molecules which are present in a container, gas molecules. Now along with this, some other gas molecules are also present, and these are also gas molecules, means there is a mixture or homogeneous mixture is there. Okay. Now the yellow color gas molecule producing the pressure of A, and blue color producing the pressure of B here. The total pressure in the container is the sum of the partial pressure of A and partial pressure of B. Means you have to sum up all the pressure produced by the individual gases. And for this, what are you going to write? P of A plus P of B. Partial pressure of component A and partial pressure of component B. Now, already we know that how to calculate the partial pressure of A, because from the Raoults law we have written here, right? Let me show here. Here we have the equation. Let me put this value here. This is a P naught A into mole fraction of A. And along with that, we have tried the P naught B. It is here. The P naught B into mole fraction of B we have. Now, this is what we have right now. Okay. This is the P total. Let me write P here. I not want to write here P total. P I will write to simplify this. Now what I will do that, I know that xi B, if I take xi B is equal to, because you know that mole fraction, sum of mole fraction of A plus mole fraction of B, if you take, it's always equals to 1. If I write here mole fraction of B, then I'm going to write here 1 minus mole fraction of A I will write. And the value of xi B I will fill here. Okay. So therefore P total, that is P, that is a P naught A, xi A plus the here P naught B is there, I will write as it is P naught B. Then xi B is there, no, I will write here 1 minus xi A, that is 1 minus xi A. Okay, in the next step what I will do that P equals to P naught A into xi A plus I will multiply this P naught B into 1, that is P naught B, and minus I will take, that is P naught B into xi A. Now you can take these two terms as one side. The P total equals to, you will get here P naught A into xi A minus, that is a P naught B into xi A. And along with that, we have left this term, we keep it here, P naught B. Okay, so now even you can, one more step you can take and simplify this. You will get here P equals to, or P total equals to, that is P naught A is a common term here. Okay, it's correct now. It's okay. P naught B is common term, and yes, okay, okay, we'll write here P naught B here, then plus bracket. Okay, we have to take the one common term, that is xi A is a common term here. Then we write here P naught A minus P naught B. Okay, so P naught A minus P naught B into xi A we get, right? Okay, fine. This is the equation what we get here. And now depending upon this equation, we're going to form a graph, and from that graph we understand that how the total vapor pressure can be calculated using the sum of individual vapor pressure of the gases. Thank you for watching this video, friends.